All right, and let me just do the first bit, which is Splunk. If you haven't used Splunk, this is totally enough to justify your entire workshop just learning Splunk. Splunk is very important. It's used at least a couple of years ago, it was used by all 100 of the top 100 Fortune companies. Now I've heard QRadar is giving it some competition, but QRadar costs $1 million. And Splunk is pretty expensive, but your free version is very good. So if you click on this, you'll get this Boss to the SOC version 1. This is the original training product from Splunk. There's now up to like version 4 of this, but I thought version 1 was the easiest and clearest, and that's the one I like. And I made a couple of servers online where it's all installed, which, you know, when I first started teaching these technical classes, it was mostly about the technical details of how to install this stuff and make it work. But now, the jobs students will actually get as entry-level jobs are somebody else has already set it up and you're a security analyst using it. So I realized it's better to just have it set up going, and that's what this one has. And for people who do not have the ability to run virtual machines and don't want to set up cloud machines, you don't need anything more than a browser for this one, or for about half the projects here. So you have servers. Click on this, you'll go to a server. There's a name and password. This is just to stop automated attacks. The name is student1 and the password is student1. It's not very secure or anything, but it does stop automated attacks from trashing my server. And here's where I should mention, my Splunk server is running the free version of Splunk. This is one great thing about Splunk. They do think about education. The free version has all the features of the pay version. The only way they punish you is, first, you cannot monitor live data. Live data, you can only monitor a certain amount of megabytes per day before you have to pay, and they give you a small allocation for live data, but you can analyze all the archived data you want to. And the other way they punish you is everybody is logged in as administrator all the time. So obviously you couldn't run it in production mode that way, and of course it would be pretty easy for people to hack and destroy this server, but it doesn't happen too often. All right, so when you're in Splunk, the only thing we're ever going to use is the search and reporting tool. And there's 2 Splunk servers, so there should be enough for a class, even if people give it burdensome queries and slow it down, which can happen. This is all we're going to use. Splunk is Google for log data. And all it does is let you search all the logs from all your devices. So notice this has about 1 million events, all from 6 years ago when they were made. And if you want to know what those events are, you can get a summary here. And it will show you, first it shows you sorted by host, which is the machine it came from, machine name, which might mean something if it's your network and you know what the network is, but we don't know this network. So for us, source types is probably the most interesting way to look at this. And you can see there's some Windows event logs, there's some Windows registry events, and there's Sysmon. Sysmon is a Microsoft tool that they got from sysinternal, which gives you the Microsoft Windows event logs record too much information. If you just open a folder and open a subfolder and open a Word document, that will create like 100 events. It's crazy. It'll drive you nuts. Sysmon is a program you run on your Windows machines, and it then gives you a smaller number of actionable, understandable event logs, like a file created, a registry key created, things like that, a process launched. And it even records like the MD5 hashes of the process that were launched and the executables that were launched. It's very nice, specifically designed for incident response. So you get a simple list of important events, and that's what Sysmon does. So what's going on here is the Splunk people set up in the Amazon cloud, they set up a whole company network with several servers, and then they put all the monitoring agents on it. Now, the way Splunk works is you put an agent on everything. Your web server, your firewall, your desktops, your routers, and everything. You put anything that could create a log that's useful, you put an agent running on it, and that forwards the data to Splunk. Splunk makes a giant database of all that data so you can search it in one place. And this is essential. That's why it is such a hit. This is the leading SIEM system, Security Information and Event Manager. There are cheaper alternatives, like the open source one, ELK, Elasticsearch, Logstash, and Kibana. So you can say that all Splunk is doing is just archiving data and letting you search through it the way you could in Elasticsearch, and that's true. All it does is It does the same thing the open source product does, but it makes it prettier and easier to use, and you're paying for convenience. And, your Linux experts and your amateurs will say, well, it's not worth paying. I can just do it for the free product. But when you're at a corporation making money, it's worth paying a lot of money for convenience, because you'll get more work out of your workers because they understand how to use it. They can go to standard training classes and get industry certificates. You can hire more people that are qualified to run that product. This is why small shops and amateurs use things like pure open source stuff like OpenOffice, but all the big rich companies use the expensive pay service, Microsoft Office, Office 365, and this stuff, because it turns out to save money in the long run to use this industry standard product that has all the conveniences. And that's what Splunk is. It's the luxurious product. Anyway, so all these things are forwarding data in. These are Microsoft Windows devices sending their logs to Splunk. And here's a FortiGate firewall sending its logs to Splunk. Here's an IIS web server. There's something about a Nessus scan. I've never used that part of the data. I'm not sure what that's about. And then there is stream data. Stream data is a Splunk module that monitors network traffic directly. It does not store full PCAPs from which you could reconstruct everything, but it stores quite a lot of information about connections, and we'll see it has a lot of information about HTTP requests and replies here, and all these other protocols like LDAP, SIP, and so on. And then there's Suricata. Suricata is an open source intrusion detection system. It detects suspicious network traffic, and it raises alerts about things it recognizes as malicious, and all of those are forwarded into Splunk. So that's all the events that come in here. So if I search with just say a star, which will show me everything in Splunk, I run the search and it finds 0 events. Now the reason it found 0 events is because by default it only looks in the last 24 hours, and all that data is 6 years old. So I have to switch to all time. Now when I do that, it's going to find 1 million events, and that's ridiculous. The time it takes to do a query is limited by the number of events it finds. So I'm going to turn on sampling, 1 in 1,000. It's only going to show me 1 out of every 1,000 events to make it faster, because I just want sort of an overview of what it's going to look like. So now I'm searching everything, and see I get 900 events because there are really 900,000 events. And so these events are just log events. So here's something completed successfully from Sysmon. It created a registry key. Here's more stuff like that. You can scroll through events one by one here and look at them, but that is usually not worth doing unless you have somehow restricted yourself down to just a few events. As you can see, these are just random events from different sources with different formats. Now, the fields, Splunk has a parser that goes with each type of event where it removes the important fields and it puts them here on the left. Every event has a host, source, and source type. As you saw before, the host is the name of the machine that sent the event, and the source is, and source type just refer to what type of event it is. And then there's other interesting fields here like bytes in and destination IP and duration and things like that. And you can click on any of these, like there's data going to IP addresses. If I click destination IP, it'll show me the top 10 IP addresses these events refer to. And you can filter things down this way. So we're going to use these fields to narrow searches. And everything's just done in this search bar that works pretty much the same way as Google. So let me go to my instructions and make sure I haven't skipped anything. Technically, by the way, all this data can be referred to by this index. In a real corporate network, you have a complicated network with different locations and different VLANs and a finance section and a marketing section and other sections. And so to make queries faster, you sort your data into indexes. And in this one, the index is bots v1, boss of the SOC v1. That's all the data we have, so we don't really need to specify the index. But in a real corporate network, you would always want to include the index to say what part of the network you want to get events from. So this will give me the same thing. It's not going to give me 925, now it gives me 922. When it gives you a sampling, it's a random sampling. Anyway, so that's just looking at all the events in the network, and that is, of course, not helping me much yet. We need to have a more clear thing. And what we're doing here, you can call it threat hunting. We're looking for evil things on the network. So we've talked about source types. So now let's look at stream HTTP events. And you could type this in if you can remember the syntax, but then you would have to spell it exactly right. And I don't like to do that. So I go down to source type, and here it is, stream HTTP. So you click on this. Now, if I didn't see it in the top 10, I would just click on one of the other streams and then fill in the HTTP. If you click on this, it will add that to the query for you in the right format. So the mouse is handy, so you don't have to remember the command line syntax. And now I'm seeing HTTP events. You'll see HTTP requests, like here's a destination content, some HT document type showing me the requested source is not found. This is a 404 error. And as you go down, you'll see various requests. It looks like you're trying to access MongoDB over HTTP on the native driver port. So anyway, these are web requests and web responses. Now, the company's name in the scenario they set up here, they based this on a Batman movie. It's just as some kind of joke. So the company name is I'mReallyNotBatman.com. So this is all the web traffic on the network. But if I want to see the web traffic coming to my web server, making requests, the simple thing is just include the domain name. Now notice here, the first two requests here are in the format name equals value, index equal bots v1, source type equals stream HTTP. You can do that way, and that was the most efficient way to use Splunk, when you know the name of the field and you set it equal to the value you're searching for. But you can also use Splunk just the way you'd use Google. You can just put a word here, like I'mReallyNotBatman.com. It will now look for events that have that string anywhere in the event, the way grep would. I like doing this all the time because it's easier. It is kind of sloppy, of course. I didn't even say what field it should be in. And technically, it consumes more server resources, so the real Splunk experts don't like doing it this way. But I do it. It works pretty well. So now I'm finding 26 events going to the web server. And, all right. And so now if I want to look at some of these events, and I'm going to lower my sampling to, say, 1 in 10, so I can see more of the events. And notice it's getting a little slow. It took a few seconds to get these 2,000 events. And now if I scroll down and look at these events, the response is document moved. The user agent is Mozilla. And here's the source headers. This is what I wanted to see. Notice it's a post to Joomla. And down here, it's got these fields. These are the header fields. Cookie, referrer, host, connection. These are the standard HTTP header fields. And down here it has Acunetics product, Acunetics scanning agreement, Acunetics user agreement. So this traffic is not coming from a normal user trying to use my web page. This is coming from a vulnerability scanner, the Acunetics vulnerability scanner. So this is suspicious traffic. It's not my IT staff has not approved this. This is an attacker attacking the network, and this is commonly what people do. They scan it with a vulnerability scanner to find a way in. So now I know a lot. And now, as soon as you find one of these, which are pretty easy to find, because most of the HTTP traffic in these events came from this scanner, then you can answer a series of flags. So for example here, you want the name of the scanner. Well, the name of the scanner is Acunetics, so that's bots v1 1.1. So to put that flag in, you go to the top of this page and submit a flag. You go to bots v1, and it's the first one. You put in your name. There's no login or anything. This is my special name that will not appear in the scoreboard, and then you put in Acunetics. And it'll tell you you're correct, and you'll end up in the scoreboard, and that's how you enter flags. And there's a whole series, a lot of different series of challenges. Just make sure you're on the right series. And now we can find a lot of things. The attacker's IP address we can find from any one of these events. It'll be the source of that request. So this is the request from the scanner. So if you look up here, there will be source IP right there. So this is the IP address of the attacker. And I'm going to copy it. Now you can put it in as a flag, which is fine. But what I'm going to do, I'm just going to save it for later. That's the source IP of the attacker. We're going to need that. All right. And then the web server's IP. we can get that too. Let me just rearrange my screens a little. All right, the web server IP address is going to be the destination IP of this scanning traffic. So that'll just be up here. There's the destination IP. That's the web server's address. So I'm going to save that. All right. And now you're going to find the defacement file name, and this is where you get to see the power of Splunk. What's going on here is I'm looking for traffic that went backwards through the network. Now, a properly designed corporate network has traffic direction controls, so you can only make requests to a web server. The web server is a server, and it can never be a client. So you can send requests to the web server, and it will give replies, but the web server never initiates a connection out. You should not be opening a browser on your web server and surfing to websites and downloading things. There's two reasons for that. In the first place, you will get the machine infected by malware, and that's no good. And in the second place, this is what attackers will do. What attackers will do is once they gain code execution on your web server through some kind of vulnerability, the first thing they will do is try to open a reverse shell connecting out to a command and control server to get traffic in, and you shouldn't allow that. You don't want to allow that, so a proper network will not allow the web server to ever make any direct connections outward to the internet. It's only a server and not a client. But this corporation does not have that restriction, and so we can find the traffic that goes backwards. So, what you do to see the traffic going backwards through the network is we're going to look at the stream HTTP data, and if you go here and look at client IP address, you see a couple of client IP addresses, and I don't really care about these values. I'm just going to click one of them to get the syntax correct. This is how I specify the client IP address. And now I'm going to change that IP address to the IP address of the web server, which would be an HTTP request coming from the web server going out somewhere. That should never happen. So if I run this query, looking for traffic from the web server, I get 0 events, but of course I'm still sampling, so I should turn off the sampling. Maybe I've got less than 10. I still have 0. Wait, when the check mark appears, it's done. There, I really has 0, but the problem is I left in this domain name, and this is the domain name of my web server. If I'm requesting from the web server going out, I'm going to a different domain, not that one, so I should remove that part of the query. All I want is HTTP traffic coming from the web server. This should never happen. And if I search for that, this did happen a few times. There are 9 events of traffic coming initiated by the web server going out doing something. This is traffic going backwards through the network. It's very likely attacker activity, doing something malicious from the web server. And so here is some kind of binary data, including Adobe Photoshop on Windows. This is a binary image being downloaded. And if you go down here, you'll see the request. This is all the junk of the image. Down here, here's the content type image.jpg and so on, and here's the name of the image. Poison Ivy is coming for you, this JPEG. They downloaded this insulting image and put it on the web page, and that is the next flag here. You're looking for the file name of the file that was downloaded, and now you want to find the fully qualified domain name of the staging server hosting the defacement file, and that's also in these requests. You can see the request that it went to, and you can just read it here. Down here is the host, prankglassine-jumpingclib.com, and notice it's on a funny port number, port 1337, instead of on port 80 or port 443 where web pages normally are. That's typical. This is a staging server, usually a compromised host that people will use to store malware and other things, hacking tools that they will download onto here. So it's once they gain code execution on your web server, which we haven't really figured out how they did that yet, but somehow they did, they then used that access to fetch a defacement file name and deface the web server. So that's what happened here. And therefore, we also know the IP address of the staging server. And let me see if I can get a parsed version of this. Is it this that does it? Yeah, now I can get one that's parsed into fields. So the client IP is this, which is my web server, of course. The destination IP here will be the IP of the staging server, and that's useful information to hold on to. That's the staging server, they call it, where the bad guys host their malicious stuff that they're going to download as part of their attack. So there's more flags here. We found the fully qualified domain name, and that gets you started. So let me stop this video.